Hi, my name is Richard Jennings, and this is my colleague Mark Frazier. Our project is on the AC active load.
Our device is designed for testing three-phase sources. Typically, when testing a three-phase source, you need to test it with a lagging load, a leading load, and preferably a unity power factor load. Unfortunately, you would have to build each of these loads and test on each of them. You could do this mechanically using a single large device by controlling the speed of a rotor. Unfortunately, that rotor will be approximately 3 tons, so it's not a very portable device. We were hoping to do much better. Our device operates by interrupting the current flowing through the system in order to shift our current waveform away from our voltage waveform to produce a different power factor.
Now we'll demonstrate what we have working properly.
Here we have our DC chopper, designed for controlling the real power of the system. The current comes through this bus to this resistor bank, then to this switch. This transistor opens and closes in order to interrupt the current, which is otherwise a DC value. The voltage is likewise a DC value between these buses. When the system is in action, it produces an average power that you can control by increasing or decreasing the length of time the switch is in the closed position. The DC voltage and current are supplied from the three-phase source through the means of a converter. In this case, it is simply a rectifier. Our original design, however, calls for a bidirectional converter that we can use to control our current waveform by opening and closing the switches as to take small pieces of the current from each phase to produce a total waveform. In this method, we can actually control the phase angle of our system.
Now we'll put power into the system and see what kind of output we get at the load. So, is everything turned on, Mark? Alright. So, first we're just going to turn the current very low. We'll put it at about 0.1 amps just for this demonstration. Notice how it's 1.17 watts, roughly. It'll fluctuate minorly. Alright, Mark, now go ahead and switch the knob.
Here, I am decreasing the pulse width of the switch.
Notice as he decreases the pulse width, the power decreases as well.
Now I am increasing the pulse width.
Notice as he increases the pulse width, the power increases. Now, if you come closer, you can see the actual pulse width. Over here.
When I decrease it, you can see that the voltage remains constant, but it breaks. The actual voltage level is steady. However, as the pulse width increases and decreases, the total current flowing through the system changes. This is a demonstration of the pulse width modulation in action. Here we have the circuit we use to control the switch. It's powered by 18 volts and uses an opto-isolator to separate the signal source from the actual driver circuit. From there, it's a relatively simple circuit to send input pulses to the input terminal on the MOSFET. The opto-isolator actually inverts the signal we send, but that doesn't really matter as we can still change our pulse widths.
Unfortunately, we were unable to get the entire system working with the controllable power sent to the load as well as the controllable phase angle. The part that we did not get working was the phase angle. As you noticed, the only thing that we were controlling was the amount of power sent into the load. However, if someone wanted to continue this project, they could replace the 6 diodes that we have shown here with 6 MOSFETs with heat sinks. And if you come over here, you could actually see those that we took them off to replace them with diodes. These are the other driver circuits that we actually built already. If you place these into the system and hook it up to the microprocessor that we selected and program it properly, the phase angle will be controllable as well.
Well, I think that about wraps it up for our demonstration today.
So, again, my name is Richard Jennings, and this is Mark Frazier, and our project is the AC Active Load. Thank you for viewing this presentation.